Hi, it's Gadget UK here again, back for the third part of the BBC here. Now there's not so much to repair here other than finishing off the case, but I'm going to take the power supply out first. We'll have a look inside the power supply. I'm not convinced that the power supply has been completely recapped actually. Just looking at one of the cap kits that Ant showed me a picture of recently, looks like it's just 4 capacitors that the cap kit comprises of, and I'm sure there's an awful lot more than 4 capacitors in there. Certainly another 3 or 4, maybe 5 or 6. So, and the other thing is, I'll show you later, but I've done the RGB cable for this, and also with the composite, both those, either the composite or the RGB cable. Just occasionally with certain games, I kind of just get a bit of flickering going on, and I just can't help but wonder what's going on there. I don't think the caps on the motherboard would cause that, but I'll perhaps recap those as well in this video. But right from the start here, I think we'll have a look inside the power supply and see what state that's in. So to get the power supply out of this, we'll disconnect all of these connectors here first, 7 of those. That now means that the power supply should be free from the motherboard. And then we'll flip it back over and remove the 2 or 3 screws underneath. Yeah, you can see the screws here, those 3. If you just tilt this at the right angle, you can actually get it out there. It's deceptive, looks like you can't get it out. So yeah, this is what I thought. You know, like these caps here, that will have been replaced. That X2 cap there, there's probably another one of those somewhere. Might be under here. Yeah, I think it is. Can you see that down there? One there. And I'm guessing 1 or 2 of these electrolytics might have been swapped out, but they all haven't. You know, I mean, look at that one there. That's a bit of a weird angle. You see that? So I think I'm going to be certainly taking these off and checking them on my cap meter and stuff. The board's pretty clean. Yeah, we'll have a look on the underside anyway. I'd like to check to see for dry joints and things like that, and just see what the solder connections are like. So we'll need to cut these 2 cable ties off here. I can always just stick some more cable ties on there later. And if you just push these clips in here, that should free up the auxiliary connector. Unscrew your nut there to free the ground strap. And then I think we're going to need to pull these off here actually as well. Yeah, so I've got live and neutral onto the top there from the cable, and then these bottom contacts here go to the actual board, you know, the power supply itself. It's super hard to get apart, seriously. Oh, there we go. So hopefully enough things should be free now. Should be able to get this out maybe. Certainly a challenge. Well, some serious swearing going on off camera with that. Seriously, you've got to take the switch out as well, and there's a ground strap on the other side as well here. It's just a logistical nightmare trying to squeeze that out that gap. Without removing that switch is impossible. So let's have a look on the underside. Yeah, it doesn't look too bad. I mean, you can see clearly that that's been replaced, that has been replaced, and that one there has been replaced. Yeah, we've got some what look like cold solder joints around here. Can you see that? That's not so clever around there in the middle. So I'll have a good inspection around there. Yeah, this is why I wanted to go in here, because I have had the odd issue where it's behaved strange, you know, and I've switched it off and on and then it's alright. And when it warms up, it's more reliable than when it's cold. And can you see here? That's actually a crack. I don't know how well you can see that. There's a fracture all the way around that point there. It's very clearly a dry solder joint there. I could probably move that there, I don't know. What's on the other side? Yeah, it's actually one of the transformer windings, that. Yeah, so I found in total about 4 or 5 points on there that I would certainly reflow. I mean, I'll give you an example here. You're not going to be able to see them very well. Can you see there, just the top of the thing? Let me see if I can zoom a little bit. Can you see there? That looks like a crack. Now they're not cracked all the way around they're just cracked on one side. So there's a few like that, but the one I pointed out before, that little connection on the transformer, is a bad solder joint. You know, that would cause problems when it's cold, probably. But what I'm going to do, I've got some Panasonic caps here. I think they are. I vaguely remember getting these. Yeah, I'm pretty sure they're with Panasonic, they look like Panasonic. So I've got some 1025 volts, and there are 3 1000 microfarad caps around here. You can see they're pretty beefy things, actually. Sorry, it's zoomed way too close there. That one there, 16 volts, I think, 1000 microfarad, 16 volt 1000, 16 volt 1000. So those 3 giant blooming caps can be replaced by these smaller ones. You're going to get less heat generated there, more space between components and things. And they're going to swap out this 16 volts 2200 here with one of these of Ali's. Now the brand I'm not sure about, Forever, never heard of them, but they look good quality, and Ali used these in BBCs as far as I understand. I've got like about 20 or 30 of these when she recapped these. And I've got, incidentally, I've got a load of these X-Class and Y-Class caps and stuff as well, actually, that she, again, well, probably just X-Class, yeah, that she used for recapping BBCs. The main caps on here, they look alright to me. That one I think's been swapped by the looks of things. Yeah, I think that was a good decision. Whilst these are a good brand, as you can see there, the Nippon Chemicon, if I smell it, it can smell electrolyte. I could smell electrolyte as I was removing it. Now there's nothing appears to have leaked out, but I could smell that fishy smell, and you can see there's nothing on here. So I just suspect that these are not in great condition, actually. And these are the ones, like I say, the higher rated voltage, they're 105 degrees, and they are Panasonic. So there's I see no reason to keep those other ones in. Yeah, so the leg spacing's a bit sort of less than desirable, I guess, but we can fit them on there. Yeah, that's not going to be a problem, as you can see. So they're going to be, you know, a smaller profile, take up less space. So yes, I took the old one off. I can smell electrolyte, even though it looks dry under there. If you sniff the under there, it smells of electrolyte. And as you can see, you know, it's much smaller, much lower profile, but higher voltage, you know, up to 35 volts, these ones, I think. And the Panasonic, so they should be good. So that's 2 down. You can see I'm marking these. I think I'm going to replace that one and that one as well as this one. So that'll mean all of these in the secondary side here have been done. As far as I can tell, that one's been swapped out. It's a Rubicon. And obviously those 2. So it will just leave these, and I think they're okay. They look alright. I can always swap them out at some of the later date for something smaller and a bit more reliable perhaps. But I think they'll be okay. But every one of these, as I've took them off, you know, if I sniff the underneath, they smell of electrolyte. But I'm having to heat up the desolder station here, actually, because I've not got enough heat with my 15 watt iron on its own. These tracers on here absorb an awful lot of heat, actually. Yeah, and I do have some spares for the 125 volts. I put 150 volts there. These look like Nichicons or something, I think. They look a good brand. So I'll swap that final one out, and that's all of those then done. So there we go, all reassembled. That was painful to do, it seriously was. It wasn't so bad putting it back together, actually. It was taking it apart that was the big problem. So yeah, all the caps redone there, and about several, you know, 7 or 8, 9 maybe, solder joints cleaned up on the underside there, all the flux removed. All the screws are back in, my nuts and things are in the right places here, I think. It's always worth inspecting. Make sure you've got your earth connected, you've got good earth connections before you power this up. Just double treble check everything, actually. And before I forget, we need 2 cable ties here. The cable ties sort of went round here and held this in this corner, if memory serves. And as you can see, what I've done here is just go for a cheap PS2 cable. Now these are pretty good, actually. I've ordered a few of these and they give a crystal clear picture. So what I'm going to do is chop off the PS2 bit here and stick the DIN on. That's the nice thing, is that these are pre-wired. The only thing I need to do is pull the wires out here, inside here, and stick some resistors in series. But it means I've got, you know, the cable of the right length, and it's already got the SCART, you know, socket here as well. And I do already have some spares of these. I could have just ordered the cable myself and made one of these separately, but it just speeds up the process. And like I said, this was like literally £2 for this cable. You can't buy cable for that price. So I've snipped off the connector there. I always leave a little bit of length there because I could always use that for something else. You know, if I ever needed to make up a special cable for a PlayStation, I can always use that connector for that now with some heat shrink. Just slide that off. So what I've had to do here, a few different things actually. I've used 330 ohm resistors to drop the red, green and blue. Same on the composite, you know, the sync signal here. And as you can see, I've put some heat shrink. Let me just pull that back a bit. You can see there's a 220 microfarad cap on each one of these as well in series to block the DC, because you do need that really. Looking at the schematics, you know, they come straight out of transistors there. Well, there's through resistors, but there's no capacitors in the way to block the DC there. So you know, you do need those caps there. So I've encapsulated each one with a piece of heat shrink tube in here, as you can see. I'll get the hot air onto that in a minute. I just need to adjust these a bit before I shrink them to make sure they're optimal, but then they should be able to bend them out of the way. That should all fit together. I've got a 100 ohm resistor there from +5 to the blanking, you know, switching signal to, well, there's two things. The 5 volts goes in here to switch the TV into the right channel, and then it goes across that 100 ohm resistor there to switch it into RGB. So that should be okay. Now, one thing I was surprised at, this cable is not fully shielded. The other PS2 cables I've got are actually, so I mean, I would have been better off using another one of the PS2 cables really, but it isn't really a big deal. Because there's two other wires in here, as well as the negative, you know, the ground. There's two others that aren't used, and those are going to be wrapped around the ones going in here to a degree anyway. So all three of those have joined up to ground here. So yeah, it's not as good as fully shielded. And even better than that is having separately shielded cores, you know, so you can have each of the red, green, blue and sync all with their own shield. You get a cable like that, it'll be super thick, but it'll be the best cable you can get. But I'll guarantee this will look absolutely fantastic when I connect it up to the TV in a minute. But as far as I can see, you absolutely need the caps there to block the DC. So there's the DIN end back together, and you can see this little fly lead here to go to the audio. That should do. The main thing is once it grips the cap, it won't move around. That's the main thing. We don't want it to shift. Yeah, that's pretty firm there, so I'll do the same now with the others. So recap the power supply, back over to the RGB lead. I'll just show you something. If I switch this on, did you notice there was no sound there? And I'll point you the TV. So I'll just switch it off, switch it on, just listen. No sound. Now, I spent a good half an hour messing around trying to work out why there was no sound there, and actually all it is because the RGB cable takes, you know, it takes time for the TV to switch over to the RGB channel. You don't get the sound. You know, the TV's muting it, and I can demonstrate that if I go into the menu here and we load a game up. Let's load Bubble Bobble, because that's got some music on the as soon as you start the game. You'll see, press 1. There we go, we've got sound. So yeah, that did confuse the hell out of me, if I'm honest. So you can see how sharp it is. I'll put a clip of comparisons there, but just watch this. So this flickering, I've been trying to make sense of this. Now it did a little bit, and then it's okay. I think as it warms up, you're getting some drift there on one of the clocks, you know, like either jitter or just a subtle, you know, some sort of drift characteristic or something in the frequencies. I'm sure that's what it is. I'm just wondering if it's one of the crystals needs to be grounded. There is a variable capacitor there, but that's used to adjust or to tweak the colour burst frequency, I think, because I experimented with that a little bit before to try and optimise the composite. And I can perhaps show you that in a minute, actually, the difference that makes with the composite. And there's definitely some drift there in that composite circuit, actually, because you can dial it in perfect, you know, tweak, and then it's absolutely perfect. The composite, you know, picture is stable, and then, you know, you leave it for 10 minutes or so, it warms up a bit more, and it starts to drift again. But you see that there, look, it's sort of flooding out, it's, you know, going nuts. There's something clearly going on there, and it seems to be more susceptible in certain screen modes. So I think the next thing we'll do here is replace the caps on the motherboard here, and I've got two transistors to swap out actually. You'll remember the one from the previous video here with the problem with the colour signal, and I put an equivalent in there, something like a BC54 something, and it shouldn't be, it should be a BC259 I think C, or something like that, 249C, I forget the part number. And there was another one as well, I forget where that was, and it was related to the around that same sort of the circuit. I think it was actually the Luma, a BC308, or was it 309, and I think I put a 308 in, or vice versa. Again, I thought there was a fault there, and in retrospect there isn't actually. I took the transistor off and measured it later and thought actually it's okay. Not the one on the Chroma, but the other one, the one on the Luma. And if there'd been a problem on the Luma, I would have spotted it. So at the moment, like I say, we've not got the right transistors in there, we've got equivalents, so I'm going to swap those over for the exact transistors that are supposed to be on there. But we'll swap out the few electrolytics. There is not that many actually. There's the one on the keyboard here, and there's a bunch of these 47s. I've got some of these as a replacement of the same package, but the others I've only got the ones with the pins come out the bottom, you know, so it's, I'm going to have to use a bit of heat shrink or something, or some tube in there to isolate. But there aren't very many. There's about 6 or 7 caps on there, but we may as well do those at the same time as I swap out those two transistors. So in the previous video there, I had not found all the washers. And after Anthony pointed out that it wasn't smashed, and have a look inside the packaging, I found 3 more of the washers actually, so I've got all 5 washers there. So I swapped my 2 transistors out. I just removed the first cap here, so I'll get a replacement on. It's negative that way, I think. So we'll tackle the one over here now. This is related to the speech side of things, I think. So it's not actually going to be utilised at the moment. Well, I think it is. It's in that area of the board. It's right next to the 2 chips there. So it's either going to be a bypass, you know, smoothing cap, or maybe coupling the audio signal there. Hold it from the other side, heater side at a time, until we can feel it start to slide through on that side. One side it will always be more problematic, depending on how big the rail is. On the other side, you know, the traces and the pads. There you go, that's off. And the holes are pretty clear there, so we can get the new one on. And we may as well clean up the top side of the board while we're here. Can you see it's really dirty around there, where that cap was? Yeah, that's the problem really, you can't get it, look at that, you can't get under things, you know. Make sure you leave long enough to flow through to the side. Sometimes what I will do is get a little bit of flux on the other side afterwards, and add a little bit of solid to the other side, especially on something like this, where you want you know, super good connections. It's not that essential, to be honest. The via will carry it to the other side anyway, but cosmetically you'll get a nice clean job doing it that way. Whilst we're here, I'll show you that one bodge wire from the previous video. Yeah, I was mistaken, it wasn't one of the smaller chips, it was on one of the larger chips here, so just from a via to one of the pads over here. So that's our main board recapped. There's a couple of 10s and a 4.7, 47, and then a 47 and a 47. And there we go, there's the 22 on the keyboard swapped out as well. So again, it's a higher voltage rating, it's 25 volts I think, instead of 10 or whatever the original one was. So after recapping the logic board, we've still got the same problem with these minor graphical issues occasionally. See that? And it looks like it's going into sort of a double height mode. Just watch. See if I can capture this. And I might even be able to do a pause for you or something, so you can see. But if you'll watch this text there, it like doubles in height if you stare at the right place. You get that green line in the middle. So there's something going on somewhere. There's another glitch or a fault somewhere, I think. I'm wondering about the video ULA. It's got its original one back in, but you see it was perhaps powered with that jumper on there for a period of time when it shouldn't do. So I might try swapping over to the other video ULA to see if that makes any difference. Okay, I'm seriously managing to confuse myself here. Either I've got some faulty video ULAs or a fault somewhere else that's just confusing matters. I've put the 2069 in here, the VC2069, and I was just getting the black screen with no jumper in either position, not making a difference, pretty much a black screen. We've booted okay, but just no video. So I started thinking, okay, is this now faulty, the 2069? And then I thought, well, when I got it working, I didn't show it, but when I got it working to start with in the previous video, I removed the wire from pin 27 to pin 1 on the IC10. At that point it started working, and then I started thinking, oh, hang on a minute, maybe I need to remove that wire to get my other chip working. And lo and behold, it did actually work when I removed that wire, but then I realised you needed that wire there. So that's why I put it back on to use this one in the previous video. But what I didn't test is whether it would work with the jump this here without the wire and the jumper to the left, and it does. So it would appear that the wire is only needed for the VT2023, I think, because this is booting now. I'll show you, and if I point you the screen, you can see it is coming up, and if I go into mode 1, that's working. Mode 7, it's working fine. So I think I'll connect up the Turbo MMC, load a few games, and just see if that solved the flickering issue. So seriously doing my head in this BBC, if I'm completely honest. Just when you think you're at the finishing line, you're not, you've got like another 10 laps to go or something. I mean, you can see how bad it's flickering there. And it seems to be going double width height, you know, not width, double height. Yeah, that's what it looks like. I can't really tell, it's that blooming quick. It could just be a sync issue. Yeah, you see there's a sync issue there, because, yeah, but see the sprites just kind of look double height there. Would the sync cause that? Yeah, I mean it could do, I guess. But it's on composite and it's on RGB. So I need to look where the commonality is there. Well, it's the sync, isn't it? And try and backtrack. You see, what worries me is I've read a number of threads on this, people who've found this issue with some BBCs, some TVs, and they never found a solution. You know, there's one guy who replaced all the circuits around the sync generation there, including one of the TTL chips, and it made no difference. Yeah, so just looking at the schematics, you can see the 6845 here, and if we scroll up a little bit, can you see these two pins here? HS and VS, horizontal sync, vertical sync, going into IC4174LSO2, and that produces your C-sync signal. So this is going to be the culprit, I think. If anything's going wrong with the sync, it's going to be here. And scrolling across the right hand side of the diagram there, you can see that C-sync signal goes here, and it comes out and goes into this 74LS86, is it? An XOR? Yeah, it is. So, yeah, I mean, it could be either of those, but I'm inclined to think that actually it's going to be the C-sync rather than this chip here. You know, it's going to be the gate before that, the NOR gate. So I've got IC41 piggybacked with a 74HC02, so that's the CMOS version. No flickers so far at all. We've got one there. Let's just see if it's any better. I mean, bear in mind it's going to be fighting out whatever's below it, but the fact it's significantly better. A minute ago it was just flickering like crazy. It was out of control. So we'll see if that's any better, if that's okay now. If I test it for 10 minutes, if that's any better, I'll remove the ones on the board, socket it up, and we'll try it with a HCO2. So I added some solder and flux. I'm just going to go round and remove the solder with the solder socket here. It's going to take a minute or two, but yeah, you get the general gist. So there we go, chip removed. Another tip, I don't know whether I've talked about it before, but when you've desoldered from under the underside, it looks fairly free. The other thing you can do, you know, obviously I've shown the thing with the pliers you can do on the underside, but you can also push into the sides, you can't see that very clearly there, push into the sides there and they'll snap off. Now you will indent, can you see, you make little marks, you know, you're pushing the pins inwards a bit. So if you were planning on reusing this, you'd need to straighten the legs up later and remove the solder and stuff, but that can work as well. I've just done that in order to avoid risk damaging any pads, because I want to get it off there pretty quick actually. So we'll get a socket on there. Is that going to be the right size? That might be a bit big actually. Yeah, I need to go find a socket of the right size. Yeah, that one's a bit too big there. And then we can see what difference that makes with a new chip on. When you get a socket that's been sat around in a component tray for like 20 years, the legs become a little bit tarnished, and when you can solder it, you get like weird blobs and bubbles and holes and things. It just doesn't solder right. So I soldered the first pin and thought, oh, and straight away I could tell, you know, this is going to be one of them blooming sockets where I get an absolutely awful join, and I have to heat the pins for a prolonged period of time, use extra flux, and I really don't want to go down that road. I hate it when that happens. So yeah, just file your socket. Yeah, that made it super easy. It went straight on, no issues at all. Solder flowed really well, but I could tell, I just knew straight away, as soon as I came to that first pin, the way it was not joining to the pin just made me realise, yeah, it's going to be one of those ones. So I do believe that's fixed it. Now you still get the flicker when it changes modes. That's to be expected, really, especially with a modern LCD TV. Sometimes my screen will go blue just for a second while it tries to lock on, but most of the time it switches just with that little flicker. Watch, you'll see it flickers back there like that. That's kind of normal. I'll test Arcadians again in a minute. I did have that on for a good 5 minutes before this, and it was stable, absolutely rock solid stable, no issues whatsoever. And that's the first I've seen it so robust, actually. So that chip was either on its way out, or the CMOS equivalent is actually helping there. I mean, CMOS chips are faster generally. That could be a factor. There's going to be subtle differences on the levels there as well, I would think. But it's solved it. Out of interest, like I say, I'm going to go through my component drawer, see if I've got an LS02, and we'll try replacement LS02, just to see if it's the same with the replacement LS02. Was it just the chip that was glitching? Or, you see, there you go, occasionally when it switches modes like that, my TV does that. I can live with that, I'm quite happy with that. It's quite rare, it doesn't do it all the time. But none of that sort of squashing down half height, just when it's just displaying the screen like that now. You know, this would be flickering up and down and, you know, like losing a frame or something with a sync or a scan line or something. You know, the sync was just not quite right there. So you can see on Arcadians there, it's absolutely rock solid. Start another one. So either that chip was faulty or the CMOS chip is helping. It's one of the two. But the work I did to recap was well worth doing. It certainly does 1000 microfarad caps in the power supply. Smelt of electrolyte. Fantastic. Yes, I've got a 74 LS02, so let's swap that out. We'll take out the HC chip there. Careful. There we go. And we've got a brand new 74 LS02 here. In fact, it's so brand new, the legs are gull-winged. Let me just straighten the legs out a bit like I showed on the previous video, just rolling it on a flat surface there. And I'll get it to... There we go, so I've got a 74 LS02 in. Straight away it's back. That is interesting. So I think, there's a few things to consider here. The composite sync is going out of that chip. So the size of the resistor and caps and things you use to couple that with the TV are going to have a factor. You know, that's going to have a factor. You know, the resistor is going to affect the level of the sync there. Now, bear in mind, I'm using an 820 ohm resistor at the moment, which I calculated based on between 4 and 5 volts to get approximately the right level of about 300 millivolts, I think, which is what it should be. But it's just interesting, it's jumping all over the place with an LS chip. It could be that, I don't know, I don't know. I honestly don't know. What I do know is I've read a lot of people got this problem, and if I swap that out for the CMOS chip, yeah, it's fixed. The CMOS chip is required, so consider that either a mod or whatever you want, I don't know. Just bear in mind, like I say, I'm using an 820 ohm resistor, and it works perfectly for me with a CMOS chip there. Sweet. So something to point out from the previous video, you've got a little variable resistor here. You can adjust that to adjust the speaker level, and you can see what I did. Instead of soldering onto the cap, I added you know, a little pin header socket here, and heat shrunk it, so I can connect my line out down there in place of the speaker. And on the LED here, I've got ground from one of the RAM chips over here, and one of the bypass caps is providing the positive connection. Originally I had the resistor leg soldered to that, but because it's stiff, there's no flexibility. You know, it would break off after a number of times, where I've got some flexibility there now because I've got wires joined on. This BBC is seriously doing my head in. As you'll see, we've now got language, and it doesn't matter which slot I stick the basic ROM in, it just comes up with language all the blooming time. We've got a fault somewhere. Now, it has been doing this intermittently, just on and off, not very regular. It's done it like 2 or 3 times since I got it, and when it's happened, I thought, that's strange, you know, I've only just reassembled it. I took the lid back off, took the basic ROM out, put it back in, switched it off and on, and then it's been alright. So I thought it was a bad connection, but it doesn't appear to be a bad connection. There's something gone wrong with the decoding. So I just thought there was a dodgy socket, and it started doing this a minute or two ago, and it wouldn't pick up the basic ROM, and I tried in every single slot. I swapped over to the spare basic ROM, the same thing, and then after a power off and power on, stuck with a constant tone again. So something else has failed, and I'm guessing it's probably going to be to do with the address decoding, the selection of these ROMs here. That's what I think. I think that's the clue why I've occasionally just random, it's only happened about 3 or 4 times, but I suspect that's what's going on. I've been testing, well, I've just removed all the bloody chips again, you know, swapped out the CPU, you know, logic probe on here, checked the reset. I'll show you, we've got the brake working. If I hold it on the reset pin, press brake, that's working. Swap my wires around, all the stuff I covered in the first video, including, you know, swapping the 7.4 LS245s around here just to rule that out for the RAM, swapping the RAM block over to 16K, same, no matter what, just the same, won't work. So we have another problem. I might need to get the logic analyzer back onto this anyway to see if I can work out what's going on, because at the moment I'm totally in the dark. It's like, I know it's not any of the socketed chips, I know it's not the ROMs, but the clue is the address decoding, the fact it couldn't find the basic ROM. So I think I'm just going to look at the schematic and target the couple of chips there, piggyback them, and just see if that makes a difference. So I could be wrong. I've been following the ROM selection here. I'll perhaps zoom in on this later if I fix it. I checked the 74LS30 here. That looks okay. It's a multiple input NAND. I think it's like 6 inputs or something. And then it goes to the gate there of this 74LS139. Now A and B inputs there are pulsing, and all the outputs are high. Considering the gate's pulsing, we should get some activity here, I would think. So that's very odd, actually. I'll just see if I can demonstrate that. Let's try and look at the pins here. I'll just disconnect the speaker because that's going to drive you nuts. It's amazing how many problems I've had with this blooming beep. So pin 1's gate. Can you see that? It's pulsing away there on the gate input. And then you've got A, which is pulsing, B, which is pulsing, and then these are outputs here: high, 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 high. Hang on, high, yeah. So I would suggest that maybe that's faulty. Actually, that 139, it could be as simple as that. So I'm still doing it. This is going to be probably the most difficult repair I've ever done. Well, certainly when you add it to the videos I've already done already, I thought the first part was pretty difficult. The problem here is we don't have highs on the data bus. You know, you can remove the CPU and you've got lows on everything. In the first part when I took out the CPU, I think there's some flickering on a couple of upper data bits actually there, when there was no chip in. And we're not seeing that, it's just lows. So there's a difference there. That might be a clue. I was thinking about that last night. But having removed all of the chips, you know, as we did in the first one, like this chip here, that one, these 3 here, all of the ROMs apart from the OS, same behaviour, constant beep. Swap the jumper over here for the RAM, constant beep. I booted Tricky's Diagnostics ROM, we hear a click on the relay, one of the LEDs comes on the keyboard, and then it goes off, and that's it. And I've read his description of that ROM, and he says it doesn't use the RAM at all. So the fact that's not initialising, I mean, all of those things added together. The first clue was, obviously, just before it failed, it was saying it couldn't find the basic ROM, and it kept saying it couldn't find the basic ROM, no matter which slot it was in. Changed the basic ROM, still couldn't find the basic ROM. Then it died. So we've got address decoding, ROM selection. That could be an issue. I'm thinking clocks. The point where it slows the clock down to 1 megahertz, stretches it up to 2 megahertz. And I think there's like an in-between clock somewhere, like 6 megahertz or something, that's derived from some maths of, a combination of 2 sig2 of the clocks, and then a resistor capacitor network to sort of sharpen the edge out of one of them or something. It's like, I don't know how that works, but somewhere there's a clock that's concatenation of 2 other clocks, if you like, or a division. So maybe we've got a problem there. The video chippy is not initialised. The V-sync and H-sync pins are just not outputting anything at all. So we know it's not got that far in the boot process. But one of the things that makes these difficult to work on, in my mind, is the blooming keyboard. You've got this reliance on the keyboard. I can't help but wonder if all we've got here is a fault on one of the TTL chips here. So this is where it just becomes a minefield, an absolute minefield to work on one of these. I would have much preferred they'd not put any reliance on this at all booting up, or at least give you a keyboard error or something. Initialise the display and stuff first at least, and then test the keyboard and give us an error. Don't just not start because the keyboard's not there. That's just crazy. So the next step here is to start probing things, because I'm just totally in the dark here. We'll switch it on to DC coupling, and I'm just going to go around the CPU, around the ROM, around everything. And I did try to do a couple of basic logic captures last night, logic analyzer captures. And I can see this code, it's running code. That's the other thing, on the CPU, if I boot this now, you've got activity on every single address line and every single data line, which I also find strange, actually, because if it was stuck in some sort of short loop waiting for a response from something, you would expect to see some address bits stuck. But that's not what we're seeing. It's just going round and round and round. But then again, there's a lot of stuff inside the address map there. So it's sort of feasible that it's going round the entire address map as part of its, standard cycle, if you like, of running around whatever code is looping around there. Anyway, it's mystery at this stage. Trying to follow the chip selection circuitry here, actually. Just looking at IC24, I think it is. 74LS138. So got some connections here from the address bus, and I'll just show you what I've found. It's a bit of an unusual screwy sort of signal. Okay, so this is pin 1. See, we've got some additional little peaks there, so I need to have a look what's feeding that. I think it's just an address line, actually. Pin 2, pin 3, 4. So they start to look a bit more normal down here. 5, 6, I think. So that's 6, 7. Now that one's crazy. That's the tube connection. And I've adjusted the time base. It doesn't improve. It's really weird. Why would we have that really awful shittery edge there? What I do know is if I piggyback it, it flattens out to just a high. Yes, I could be barking up the wrong tree. The interesting thing is, on the input, on the inputs that, well, I say inputs, they're like gate connections and things here. I'll show you. So the interesting thing is, on these gates here, and on these ABC, we've got, highs, pulsing going on. And then on this side here, they're all just like highs with some really awful looking levels there. They just look crazy, especially like that tube one, number 7. You're like a jittery, squarey edge, and they're all high. So I'm guessing that this is the providing selects here, and in particular those via A and via B. And I'm just wondering if it can't address the via. It can't detect the keyboard because that 258 is knackered. I mean, I'm guessing, that's what I'm guessing. So, I mean, we already swapped the 139 down here on a hunch, and that proved nothing. It didn't make any difference whatsoever. So I'll socket that up just because, yeah, I don't think I'm seeing the behaviour. I'd expect to see some pulsing on one of those output pins based on what I'm seeing on the inputs, actually. So we'll give it a try. Swap out that. Well, that made no difference at all. The other thing I've been doing now is just going around some of the other multiplexers and demuxers. There's one above here, a 74LS139, I think. I'll just show you what I found on that one. On pin 6, I'm disconnect the speaker. Yeah, pin 6, which is the int on output, as far as I can see. So it's that pin there. Can you see that? We've got like a transition. Hang on, that's the voltage time base. Yeah, we've got like these little transitions here, but no ground level. It's like maybe it's trying to go low at this point and it's not. I don't know. I'm going to swap that one out as well, I think. Well, I'm getting seriously confused here. I think I've spent the last 2 days going around in circles, chasing my own tail, actually, because everything's led back to the 74LS02. That, if you remember earlier on, I swapped it out for a HC chip, and I started thinking, I wonder if that's got something to do with it. Now, I'm sure I checked that earlier on, and in fact I did. I swapped it out for a brand new. You can see here, this was a brand new one, brand new 74LS02. It's an LS20. It's my own stupidity. What I did is I swapped the 74LS02 out for a 74LS20. Didn't see the bloody digit, so I've just been on a wild goose chase swapping out chips for the hell of it. But as you can see, it's back up and running again. That's the main thing. Hooray! It's like I've spent so long going around in circles with this now. Yeah, just retracing my steps, I think what's happened here, I've had 2 faults. One of them was introduced by me, and that was the second fault, and that was by swapping over to the LS20 instead of an 02. It was just a dyslexic moment. I do suffer from dyslexia occasionally with my chronic fatigue, and I can read things and get characters mixed up, and I can type things and not even spot I've got characters mixed up. I never used to be like that until I got chronic fatigue and multiple chemical sensitivity, but nevertheless, that's something I suffer from. So when one of these 139s, or I think they are here, or even that 138, one of those has solved it. I am pretty sure that was the ROM selection issue, because what happened was, after I swapped out the 02 with a HC02, that solved my video stability issue, great. I then started to get the problem where it couldn't find the basic ROM, no matter what slot it was in. And I swapped out the kernel, the OS ROM, just the same, it couldn't see the ROM at all. At that point, it completely died. Alarm bells were ringing. I was thinking, oh my god, it's that HC chip. I put a HC chip in there. Yeah, for the video output there, merging that's going to be okay. But the characteristics of the way CMOS works compared to TTL, some things might take offence to the output or even the inputs. I haven't got a clue in terms of the current. So that was why I then swapped back to a 02, and at that point I put the 20 in. So I still had the ROM issue, but I think what I've done is, as part of the following through with the logic probe, I've addressed a couple of issues with levels not being right and stuff, fixed those have, but they didn't solve the problem. And then eventually, following the schematics there, I backtracked through the chip select logic here through to this chip here. It's just coincidental that one of the gates actually, I think it's for the dis-N pin on here. This is what I was checking on the video ULA. That was extremely low, like 1 volt. You could see it come from 0 to 1 volt. I thought, there's a problem there. The video ULA can't come up, or whatever that dis-N pin does. I don't think it enables it. Might be to disable it or something. But that pin was just like very low, that level, 1 volts. And that was when I traced it through to this chip. Suddenly thought, actually, that's a little bit warm. None of the others are. Checked that gate. I thought, yeah, there's something wrong with that chip. Swapped it out for the original one, and it sprang back to life. I put the HC one back in, and it sprang back to life. So yeah, it's just an unfortunate series of really. Just one of those things. This is the problem. Sometimes I'm like this. I've said this in videos before. I can get so stressed when something goes wrong. I start to run away like a bull in a china shop. And before you know it, I've created myself a problem, on top of the problem I'm looking at. And that's exactly what's happened. But we got there the long way round. I inadvertently resolved this by using the scope. These are the kind of problems, like I say, that can be very, very difficult to resolve. And I would suggest, if you're watching this video and you're thinking about getting a Beeb and you've done no repairs and things yourself in the past, and you think this might be a good challenge, yeah, by all means get one. You could look out, because a lot of the time it's just the vias, or something like that, or the RAM. Those things are pretty easy. But when you look at the problem we've just had here, had that chip just failed of its own accord that way, that would have been really super hard to find. It really was that the problem I was faced with this on this particular video. Really difficult. I've been tearing my hair out. I've checked so many things with both initially the Logic Pro, but then I've gone around with the scope, pin by pin by pin, all around every single one of these chips. I've gone back and forwards, jumping around. Because the other thing is, once you start to follow a particular issue, which I spotted, you go deeper down the rabbit hole. You start to follow the chips, and you're going away from the circuit you originally started to check. So in other words, you start looking at the chip select. Before you know it, you're ended up over the video section over here somewhere, the top side. And I was like, I had to stop myself a few times going, why am I looking at the video thing here, looking at these XORs and stuff? It's not relevant. So then I have to go back over to the chip select and start following pins again. Before you know it, I'm over on a via. And I'm going, maybe the via's not been selected. And then the next thing you know, I'm having to do captures with the analyzer, which I didn't show, to try and capture the chip selects to go, let's see what's been selected in which order. And then the next minute, I'm back over to the ROMs again, trying to make sense of the chip selects. Well, I'm thinking, well, actually, I think I've solved that. I still only see one chip select here, none of the others selected. You see what I'm trying to say? It's very easy to go off on a tangent, because the way, especially with the BBC here, because you look at that one chip, it's used in about 3 or 4 places, and they're different areas of the board. So when you land on that chip testing it, and then you go around testing the pins, and you find a problem there, you suddenly, you're not following the route you were to the chip to start with. Suddenly you're going off checking another part of the circuit, and that is the danger. That is the difficulty. But that has helped me. I wouldn't have found this problem had I not just gone all the way around those pins there, trying to follow one of the inputs from somewhere else. So as you can see, that gives us crystal clear RGB, but the side effect is that one of the gates in that chip is used elsewhere, on a totally different part of the circuit, to do with the chroma signal actually. And that takes offence actually to the CMOS side of things. If I switch it on to composite, can you see down here? Can you see this red band here? So that's a problem of swapping out the whole chip for a CMOS chip. And looking back at the schematics here, you can see IC41 provides this signal here to a different chip, actually to the video ULA. So this is why the chroma signal is not quite right, I think. This is why we got that red band down the left hand side. I think that this is affecting the timing when this chip is a CMOS chip. But we do need the other gate, the one that's merging the H and V to produce csync, to be CMOS, I think. Yeah, so the interesting thing is, I've just tried a 74F02, and it's a little bit better, but not, it's nowhere near as good as it is with the CMOS chip. So we've got that issue there with the CMOS chip, with the colour side of things, like it affects the timing, we get the red band. But as you can see in RGB, it's absolutely rock solid with the CMOS chip. So I'm thinking perhaps the best way forward actually is to just piggyback the chips and use the CMOS gate here for the merging of the csync from H and V, and then leave the other 3 gates on there, just connected to the board as usual. That's perhaps the easiest mod. I mean, I've got a socket here now, so that's easy to do that. It's always revertible. You just pull the chip out, stick a 74 LSO2 back in there, and it's back to stock again. But the CMOS chip has fixed it. It's just this issue, like I say, of the other gate being used elsewhere. Well, one of the other gates used on the chroma circuit. I think that's causing an issue there. That's why we get that red band down the side. And if I was to hazard a guess, I've been thinking about this, trying to speculate, trying to work out what what the cause is. I mean, obviously, the reason I went down the approach of getting a 7.4 FO2 was to rule out whether it's speed or not, because CMOS chips are faster. No, the FO2's a lot faster than an LSO2, and it's just the same actually. It's maybe a tiny bit better. So I don't think the speed is the issue. I think what we're looking at is, and then I wonder whether it's the output levels, and I don't think it's the output level actually, because it was a little bit better with the FO2. And I think what's actually happening, I think it's the inputs. I think the H and V from the 6845, is that the right part number? I think it is. Yeah, I think the H and V signals, there might be a little bit of noise there when transitioning or something, and I suspect that's affecting the levels, the logic level there. And I think with maybe when it's transitioning from a high to low, it's the issue. The low is perhaps not low enough or something. And I think with the CMOS, because of the difference there and the tolerance, the windows there between high and low, that's why I think the CMOS chip fixes it actually. There are things to think there. Could it be solved by sticking a cap somewhere on the 6845? That might actually solve that problem. And again, maybe sticking a cap on the H and V signals of a certain size. I don't know whether that would help. It might exacerbate the problem. I'm not sure. Or a pull down maybe, or a pull up. I'm not sure. I don't think a pull up would work. Maybe a pull down might, so that you get a faster transition to a low. But I actually think the cleanest way is to do what I've said, is to just piggyback it and just route the H and V through one gate on a HC chip. So as you can see here, I've got I'm doing it with the FO2. I've got a bunch of FO2s. I've also got some LSO2s, but it was a little bit better with an FO2. So I'm going with an FO2 for the underneath chip. And as you can see, I've just cut off the 3 pins here for the gate that we're not using. So I've tried to cut them as flush as possible. I don't think there's any more I can trim off there without risking cutting one of the other pins off. But yeah, what I'm going to do is I'll stick a little piece of insulation tape under and over there just to isolate those, and then all I need to do is find some way of extending these 3 legs here so they come down here. Now I mean, I could solder wires on there, it might be a bit fudgy. I'm thinking actually of just getting some little a piece of socket or something, so that I can actually plug it into there, and then the height, yeah, it might just be right, it might just fit, I'm not sure. Might need to trim the pins down a little bit, we'll see. But I can deal with that once I've soldered it on. It's not going to be the end of the world. And as I say, I can always just pull this out and stick an LSO2 back in there, not a problem. So there's our 3 pins isolated with a piece of tape. We'll just overlay this now and solder the 4 contacts. Now there is an important point here that I forgot about. It doesn't matter because I've got loads of these HC02s. They're just cheap ones from China. I've got about 20 other things. So I mean, I could always just redo it, but the unused gates, what you should do really is tie the inputs on those gates to either high or low of the unused gates, because otherwise they can oscillate. That's the thing, and one gate oscillating, going out of control, can affect other gates on the chip. But we'll just give it a try. I suspect it's probably going to be okay. The other thing I could do, as is now, without redoing it and putting a different chip on, I could just add a bit of solder onto the inputs, join them up and have a little wire on top. I might do that afterwards and then just join them all to the ground, with some little kynar wires there, because there is enough there to just very, very gently solder a kynar on there, but it would be a bit of a mess, so I'd rather try and do it without it. But we'll just bear that in mind. If we find it's glitching still, that might be something I need to do. It might be glitching worse, you never know. And I figured the best thing to do actually is to use the old legs. You're not going to be able to see this, it's so blooming small, but I chopped the legs off there, off the other positions. So if I just hold them by the very tips here with the fine nose pliers, you need ones that have got flat edges to be able to grip something so small. We'll just tin the leg up. You're not going to be able to see that, it's just off camera. And then this is the hard part, especially while the camera's there. I managed to do the 2 off camera. Just need to try and get it in place, and my hands are just shaking all over the place here. It's so small, and it just heats the point. Yeah, it needs moving a bit. There we go. So yeah, as you can see, not perfect, but if you look at the length of them, they're in exactly the right position. Just need to straighten them out a bit, it'll bend in. So there we go, our Franken chip is installed. Let's give it a go. Switch it on, so that's okay. Now the key here, we should be able to, if we go back into composite mode, we shouldn't have the red band down the left. Yeah, we've got no red band down the left hand side there. So let's go back into RGB and test out some games. And as you can see, I swapped out the connector here as well. It's just a bit more reliable. It's easier than messing around with two separate wires there. Whilst we're in this area of the board here, you can see the trim cap there. So that's like a fine adjust for the clock crystal here that provides the frequency for the PAL colour burst signal. So I'll show you the effect that has actually. It's hard to demonstrate this whilst I'm looking at the thing and trying to adjust it. If you just watch the title screen here, see it drifting, and if I tweak it, look, you can get it to go stable almost. It's nearly stable. Look at that, so now it's pretty much stable. Oh, it's moved again. And if I take the tool away, it was fairly stable a minute ago, and it's fairly stable now actually. I don't know how well that's coming across. You can just see some very faint movement on the reds. Let's see if we can zoom in a little bit just so you can see what I'm talking about, because it's going to get lost in compression. Let's just wait for the tile to come back up again. Yeah, so there's a zoom in. Can you see the reds here? You get like a pattern moving that way very slowly. Before it was moving even quicker than that. So adjusting that trim cap, you can solve that problem. You know, you can get it dialed in so that the colours, you don't get the shimmering. But what happens is you leave it for 10 minutes and it starts to drift again. It doesn't remain constant. The only way to adjust it really is to switch it on, leave it on for half an hour, then adjust it, switch it off. But then when it's cold, it'll be out again. So yeah, that's one of the problems with composite. Composite's just awful in general, but I do think that the circuit there to do with the PAL colour burst could be a bit better to stop that happening. I mean, that's exactly the reason why, if you've watched some of the more advanced repair videos on YouTube to do with scopes and test equipment and stuff, you'll see that some of them have got what do they call it? It's like a crystal inside an oven, isn't it? It's like a little metal can that's, you know, that holds the crystal, but it's an oven, and it keeps the crystal at a constant temperature. You know, it's powered, and it heats the crystal up instantly, very, very quickly after power on, and keeps it at a constant temperature. It's regulated, if you like, and they use very low tolerance components and things there to make sure that those, you know, the crystal is as accurate as it possibly can be. This has just got a standard, you know, off the shelf, you know, 5-cent sort of crystal, and if the circuit designed around that is not designed in such a way to try and compensate for any drift, that's what you're going to get, unfortunately. And ultimately, it's the luma signal that's interfering with it. You know, what we're seeing there is actually the overlap. If you imagine two analog signals, you know, you imagine two analog. Sorry, I'm quite close there, and I'll zoom back out again. Yeah, but ultimately, if you imagine two analog signals over the top of each other, one being your chroma, one being your luma, that, you know, at various points in those signals, they're actually overlapping. So one can interfere with the other, and that's exactly what you get with the, you know, dot crawl. There's no easy solution really, but that's why the RGB is the sought after option really with any system. But look at the difference, it's amazing, it's like night and day. So the interesting point I would make there with regards to the 6845, I looked up the data sheet. It's a Motorola chip originally, I think. This one might not be manufactured by Motorola, but that's who originally created them. And they're listed as a MOS part actually, but it does say very clearly TTL compatible on inputs and outputs. So there is a question there as to what's causing that issue. It could be there's just not enough bypass caps and things around that area there, because there's very few electrolytics on this board. You know, that I could have maybe solved it by just sticking a bypass cap under there or something. That might have solved the issue. I might not have needed to do that mod there with the CMOS output to merge the csync, but I just thought it was an interesting point to mention. Bear in mind, this same 6845 CRTC is used in the CPC and a few other systems as well, I think. I read somewhere that some of the PET models, I think, can use the same chip. I don't think they ship with that chip, but you can use that as a replacement. And the other interesting thing there as well is that your Rockwell do a chip as well, but I think there's a very subtle difference there in one of the two of the registers, so I'm not sure how compatible it is. It probably would work, I would think. You might need some mod if you're going to stick a Rockwell chip, no idea. If you know more, please post in the comments below. And a correction to the previous video, when I said the Domesday project, yeah, not domes as in under the dome, I don't know if you've seen that, you know, trapped inside a dome, no, Doomsday. That was how I remembered it actually, as the Doomsday project. But a friend of mine was like, no, it wasn't, it's the Domesday project. And I was like, no, I'm sure it was called the Doomsday. And he went, no, we'll look it up in Wikipedia. So I kept waiting and obviously looked up the spelling, and yeah, it's spelt that way. But I think the pronunciation is Doomsday. I do clearly remember my tutor at school saying, you know, it's the Doomsday project, not the Domesday project. It's just, you know, like I say, sometimes you question things when people question you. So there will be a part 4. I'm not sure part 4 is going to be as long as the first 3 parts. We'll take a more in-depth look at the Turbo MMC in the next part. I'll show you what's required, what you get in the kit, you know, installation stuff. And then just some different games and things, you know, we'll run through some of the different software there and a few homebrew titles. I'll show you the case. I'm going to try and touch up the corners and a little bit there, you know, the white bits with some acrylic paint. It might not look perfect, I'm not sure yet. I might even just leave it white, because it doesn't look bad actually as it is. The other thing we'll do is we'll try and get some speech chips in there. Those should be due any day now, and we'll test that side of things out. I am working on a joystick, so I might have a look at that in the next video. That might be a future project, I'm not sure. And a few other little bits and pieces. So hopefully you found that interesting. Thanks for watching. I'll see you soon.